Hai, Assalamualaikum warahmatullahi taala wabarakatuh. So, first, let me introduce our group member, which is me, Muhammad Akil bin Amrin. For the second one is Muhammad Danish bin Yuri Zulkarnain, and the third one is Muhammad Hafiz bin Muhammad Azmi. So, we choose the topic 2, which is correlation and regression. So, our topic is the relationship between COVID-19 cases and the percentage of the population that fully vaccinated. So, let's move to the first part, which is introduction of this topic. Thank you.
Thank you, Mumakil. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Muhammad Azmi, and today I will explain about the introduction of this topic. The objective of this study is to examine the relationship between COVID-19 cases and the percentage of the population that is fully vaccinated. We aim to determine if there is a correlation between this variable and what to extent vaccination rate may impact the total number of COVID-19 cases. So, what is the objective? The objective of this study is to examine the relationship between COVID-19 cases and the percentage of the population that is fully vaccinated. Specifically, we aim to determine if there is a correlation between this variable and to what extent vaccination rate may impact the total number of COVID-19 cases. By analyzing the data, we seek to provide insight into the effectiveness of vaccination effort in mitigating the spread of COVID-19 and inform public health policies aimed at controlling the pandemic. Next, I will into the effectiveness of vaccination effort in mitigating the spread of COVID-19 and inform public health policies aimed at controlling the pandemic. Next is the problem statement. Problem statement of the study is the ongoing COVID-19 pandemic has posed significant challenge worldwide, with effort to control the spread of the virus relying heavily on vaccination campaign. Understanding the relationship between vaccination rate and COVID-19 cases is crucial for guiding public health intervention and policy decision. Therefore, this study seek to investigate the correlation between the percentage of the population that is fully vaccinated and the total number of COVID-19 cases. By addressing this issue, we aim to provide valuable insight into the effectiveness of vaccination effort in reducing COVID-19 transmission and inform strategies for combating the pandemic. So next, I will give to Muhammad Akil for the next slide.
Hi, Assalamualaikum. My name is Muhammad Akil bin Amrin. So, I will continue to the next part, which is method of data collection. So, the data set used for this analysis was obtained from official website of COVID-19 cases and consists of 14 observations, which is in Malaysia we have 14 states. Utilize operation statistical tools such as Microsoft Excel or statistical software package to conduct analysis about our project. So the variable includes our variable X, which is the percentage of the population that is fully vaccinated, and the variable Y, which is total number of COVID-19 cases. So we go to the next part, which is classification and summarization. For this analysis, we have considered variable X fully vaccinated as the explanatory variable and variable Y total cases as the response variable. We expect a negative correlation between this variable, anticipating that higher vaccination rates will be associated with lower total COVID-19 case count. So let's go to the next part, which is graph part. So as you can see in this slide, we have a scatter plot of regression line. So you can understand by your own, but I will explain a little bit about this graph. So for the variable X, we have a fully vaccinated versus the variable Y, which is total cases. So the equation we get is Y equals to negative 0.0359 plus 132667, and the R square is 0.0137. So I will give you a few seconds to understand this graph. And then let's go to another part, which is how to calculate the value of correlation coefficient. So the formula is like this, and the data we get is like this. So I will read one by one the data. So the sum of x we got 9148831. The sum of y we got 1529193. The sum of x squared we got 8.93944 times 10 power of 12. And the sum of y squared we got 4.5667 times 10 power of 11. And the last one we got the sum of x multiple y. We got 8.93112 times 10 power of 11. So you can include or you can insert the value in this formula. So the last one we got the r is equal to negative 0.1169204295. So we can conclude that the correlation coefficient r equals to negative 0.1169204295. Interpretation, we got there is a weak negative correlation between the percentage of the population that is fully vaccinated and the total number of COVID-19 cases. So, however, the correlation is not statistically significant. So, thank you. So, we go to the next part, which is we continue by the my group member, which is Danish. Thank you.
Okay, so hi, my name is Dennis Shuri. So I will continue our next agenda with the equation of the regression line that we got. So without further ado, let me explain it more. These are the formula to find value of A and B because value of A and B is used to complete the equation of the regression line, which is y equal to A plus bx. In our regression equation, after the calculation that we made, the value of A, which is 132,667.282, represent the baseline number of COVID-19 cases predicted when the vaccination rate is at 0%. For B, B is the slope of the regression line, that is the number of units of increase, which is positive slope, or decrease, which is negative slope, in Y for each unit increase in X. So the final equation of regression line that we got is y equal to 132,667.282 minus with 0.03586785551x. So next we got example of prediction using the regression equation. So as the example scenario given, imagine we have a population where 60% is fully vaccinated against COVID-19. We have a regression equation which is y equal to 132,667.282 minus with 0.0358678 at 551 and will be multiplied with vaccination rate. In this equation, y represents the predicted total number of COVID-19 cases and the constant term is 132,667.282 represents the baseline number of cases and the slope is negative 0.03586785551 represent the change in cases per unit change in vaccination rate. So I will interpret the slope of the regression line, which is the negative slope of negative 0.03586785551 tell us that as the vaccination rate increased by 1 unit, the predicted number of COVID-19 cases decreased by approximately 0.036 units. This relationship holds true while keeping other factors constant. A small conclusion. What I understand from our example by using the regression line is the negative slope indicates that higher vaccination rates are associated with lower COVID-19 case numbers, and this highlights the effectiveness of vaccination in reducing the spread of the disease. Last but not least, we got the value of R2 for the regression model. This supposedly be so easy, I think, to find it. So let me explain it to you guys. So when we got the value of R, we will power of 2 of it, and we will get 0.0136 and so on. And we will multiply it with 100% to get the percentage. So the interpretation that we got is about 1.37% of the variation in number of COVID-19 cases can be explained by the population that is fully vaccinated. So the interesting findings that we got also from the regression graph, we can see that the plot is negative linear relationship and loosely plotted due to the outlier that affect the population that is fully vaccinated and the number of COVID-19 cases. Other than that, we found out that each state got different amount of vaccine distributed. This is due to the government incompetent. For instance, Sabah has the lowest COVID-19 vaccination coverage across Malaysia as of 29 August. 57.2% of adults in Sabah have received at least one COVID-19 vaccine dose, while 38% of adults have received both vaccine doses. So that's all for me. I will pass to my friend. Thank you.
Thank you so much for your time, and that's all for our group today. In conclusion, our study found a weak negative correlation between the percentage of the population fully vaccinated and the total number of COVID-19 cases. However, the correlation was not statistically significant. This suggests that while there may be some impact of the vaccination rate on reducing COVID-19 cases, other factors are likely at play. Further research with a larger sample size and consideration of additional variables is warranted to better understand the relation between vaccination rate and COVID-19 cases. For more reference, you can check our link in down below. Thank you so much. That's all today. Assalamualaikum warahmatullahi wabarakatuh.